Welcome. Tonight we are going to be studying the concept or learning more about the concept of density. And density is the relationship of an object's mass to its given volume. One thing that students tend to not understand, or a misconception, is that the density changes if the size changes. But if you look at the equation of density equals mass times volume, if you increase your volume, then your mass would also increase. It's like pouring out more water. If I poured out more water from a cup and I went from 50 milliliters to 75 milliliters, my mass would also increase. It would not remain the same. Because you are dealing with a formula of density that is mass divided by volume, you can use any mass unit. So you could use grams or kilograms or pounds. And depending on what you're studying, you will see all of these as your mass unit for density. What you can do for your volume unit, so you do grams per, or grams divided by, or kilograms divided by. What you would see for your volume unit, some examples would be milliliters, or cubic centimeters, or gallons. Once again, depending on what you're studying and who you're trying to tell the density to, they will change those units. In this class, because we tend to measure things in grams using our balances, and we tend to measure volume in cubic centimeters or milliliters, which are equivalent to each other, you will see our units of density in grams per cubic centimeter, or grams divided by cubic centimeters, or grams divided by milliliters. Okay, so now using that equation that we just wrote down or had, we're going to try to do some example problems. So this particular problem asks for the density, so I'm going to solve for density, and I'm going to use the formula of mass divided by volume. In this problem, it's sometimes very important for students to write down what they know. So for every 5 grams, I see that grams unit, I know that's a mass unit. So I'm going to write M right next to it. I then keep reading, there's 20 milliliters. Okay, so milliliters is a volume unit. I'm going to write V. It just helps so that students can get not as confused with all the numbers, because the more numbers you see, the more times students become confused on what unit goes with what. So we're going to do density equals, just plug and chug, 5 grams divided by my 20 milliliters. Solving this, you get 1 over 4 grams, and then over milliliters. Make sure you use your units. But because we measure things and 1 over 4 is pretty much an exact measurement, we try to use decimals in this class. So it would be written as 0.25 grams per milliliter. Or so for every 1 milliliter, I have 0.25 grams of this golf ball. But once again, we did learn about sig figs, so we're going to give our answer in the correct amount of sig figs. So 5 has 1 sig fig, okay, and 20 has 1 sig fig because the decimal is absent. So we'd start from the right, go to the left. So this would be 1 sig fig. So we need to give our final answer in 1 sig fig. So going from the left, because we always go from the left for sig figs, with rounding, we would start the first non-zero number, which is that 2. That 2 will round up because it will it's followed by a 5. So instead of 0.25, you would end up with 0.3 grams for every 1 milliliter. Okay, because that 5, because it's after the decimal, would drop off. Okay, so now using the density that we just calculated, this guy, if a golf ball had a mass of 10 grams, what would its volume be? So now we're just going to be solving for a different variable in the exact same equation. So we're going to do 0.3 grams per milliliter, or so for every 1 milliliter if we want. We can set up even a kind of a proportion. That is equal to, well, I see a mass unit of 10 grams. So I know I'm going to fill in my 10 grams on top. And then I'm asking for what is its volume. So X. Now volume in this case is going to be milliliters, because grams needs to be on top. They need to be the same units. Milliliters needs to be on the bottom. So you can cross multiply, and for this answer you would get 33.3 milliliters. But looking at your sig figs, once again, because you will be checked on with sig figs, we look at all of our numbers. 0.3 has 1 sig fig. 10 has 1 sig fig, and then the 1 milliliter, which went with the 0.3, also had 1 sig fig. So now we're going to need to round this answer, obviously, to 1 sig fig, because that is the least amount of sig figs. So starting from the left, we're going to count at the first non-zero number, which is that 3. That 3 you're going to check to the next number, which is also a 3. So because of that, it is going to remain a 3. This second 3 is going to turn to a 0 because it is before the decimal point. And because this 3, the last 3, is to the right of the decimal point, it will drop off. So you would end with a final answer of 30 milliliters. Okay, now this is a graph that you will have seen by now, hopefully, and we've already determined that mass should be written on the y-axis, in whatever unit you would be using, and volume would be written on the x-axis. And when you do that, the slope of this line, which is a direct relationship, will be mass divided by volume, which is the exact same thing as the equation for density. So the slope of this line is going to be its density. When I plug into the equation of a line, because obviously this is a line, y was my mass, m was my slope, which is density, x was my volume, and b for every density graph or mass volume graph is going to be 0. Why? Because if I have no volume, then I have no mass. If I have no mass, then I have no volume. So once again, what does the slope represent? The slope represents density. All right, sinking and floating, pretty obvious, but what you can do is you can actually use the density of a liquid or of a solution that you know, and you can figure out from that the density or relative density of another object. One that we will use all the time, or that is commonly used, is the density of water. And the density of water has been determined to be 1 gram for every 1 milliliter, or 1 gram for every 1 cubic centimeter. This is something that you need to memorize. Okay. Now, if an object was seen that it floated in water, that means its density is less than 1, which means that for the same amount of volume, it has less mass. Okay, so if it took up the same amount of space, it would have a less mass. If the object sank in water, then you know that its density was greater than 1 because it sank in water, and water had a density of 1 gram per milliliter. So you knew that it would have to be greater than that. When you're trying to draw these lovely particle pictures, I'm going to try to make it pretty consistent. Let's pretend this is the water. Alright, so we have our lovely water. Because these particles don't necessarily represent the exact same amount of mass, I really am not going to be particular on whether you show that you have less particles or anything like that. If you would like to, you are more than welcome to. But what I'm caring about this is that you know where it would be if it sank. Okay, and everybody should know if you're sinking, then you are going to the bottom. Okay, so this would show that this object is sinking. Okay, and I'm going to try to show that it's a different object by changing color. So this object would be floating in water. So its density would be less than water. So this would be float. Water displacement is something that students tend to be very familiar with. And what it is it's basically when you enter a bath. When you enter a bath, so pretend here's your bathtub, everybody knows that you should only fill it part of the way. Why? Because as soon as you get in that bath, what's going to happen? I'm going to pretend this is the original. Okay, and now you're getting in this bath. So here's your legs, here's your hands, here's your body. Okay, what happens to the water? Well, it rises. So this is the final one when you're actually in the bath. Well, what caused that to rise? Well, it's whatever part of your body is submerged. So if you measured this difference, that would be the amount of volume that was in the water of your body. Exact same thing happens all the time with irregularly shaped objects. So when you can't use a ruler to do length times width times height, such as this beautiful T-Rex right here, water displacement is an excellent way to figure out the volume of that object. So in this particular case, we know that with water alone, it was 4.8 milliliters, or liters, but I'm just going to assume that it's milliliters in this case. That's this guy. When I had water plus T-Rex, it went all the way up to 5.6 milliliters. Now I know that the difference using basic algebra, W I could put in for 4.8 plus T-Rex is equal to 5.6. So basically all you're going to have to do is subtract it, and you get your T-Rex was equal to 0.8 milliliters. Thank you so much, and have a great night. This is your notes on density.